and every device will become connected. And all the data after connected will be seamlessly uploaded to the cloud. And in the cloud to do the intelligent analytics analysis and become intelligent data. So in year 2009, IBM raised about the 3I concept. And this is the 3I means instrumented, interconnect, and intelligent. And in 2009, the Prime Minister of China, Wen Jiabao, he the first time to raise the term IoT, Internet of Things. In year 2009, IoT is the first time being raised as the term Internet of Things. So this is the architecture, the structure of the Internet of Things. And at Advantech, we are the global leader in the industrial computer. We provide all kinds of the computer platform for the instrumented layer, and also for the interconnected layer, and also in the intelligent layer. Inside the intelligent is actually a cloud. Inside the cloud consists of all of the computer, storage, switch to provide the internet infrastructure. Okay? And there will be, according to Microsoft and Intel, by year 2020, there will be 50 billion sets of connecting devices in the world by year 2020. And 30 billion sets of that device will be belong to the sensor. 80% of the sensor will be wireless. No matter it's a BLE, the Bluetooth low energy, or it's a Wi-Fi, or it's a 6-band, or all these different kind of protocol, it's wireless. 80% of the sensor will be wireless. And the wireless will be collect all the data of the things, okay, through the edge computer, and upload to the cloud to do the big data analytics to become intelligent data. And the intelligent data will be provided to the end customer, to provide to 7 billion of population in the world through smartphone or through computer or from iPad. So this is the infrastructure of the IoT. And then the IoT will be further evolved from the sensor layer to the IoT data gateways. At Advantech, we are the number one in the IoT data gateway. We work with Intel to design the first IoT data gateway to enable all of the sensor data will move up to the cloud. And in the cloud, we will provide a voice cloud and also enabling the application cloud. We will construct an application cloud to enable our system integrator to put their application on the cloud. And we are working with Microsoft Azure, the big data analytics, together with our own SUSE as a software to provide a big data analytics service. So in a way, Advantech will provide a 4-layer of the IoT structure, a service, the sensor device, IoT data gateway, voice cloud, and also the application cloud. Okay, so actually, at Advantech, we provide all kinds of hardware platform, from the board to the system, to the panel computer, to the HMI, and also software, provide to fulfill all kinds of application in manufacturing, in digital logistics, in retail, in intelligent building, medical surveillance, power and edge, robot, and transportation. That's our mission. So we not only provide the hardware, we will also provide the infrastructure for the smart city application. Let me show you two of the examples that's in Taiwan. So this is the IoT application in the ETC. Taiwan is the first country that has 100% ETC application. There's no toll station on the highways. So we use, every car will install with an E-Tech, it's an RFID. And we have installed 319 gantries on the highways. So they install a RFID reader and also the camera to read the card and then to record all of the message of every vehicle. And then we can calculate how much fare you need to pay to the for the usage of the highway. And this is the typical IoT application in Taiwan. And I believe you will see more and more countries will implement this kind of ETC, electronic toll collection system. And the next application I'd like to share with you is in this healthcare. So apply the IoT technology, application technology. So if you want to go to see the doctor, you can make appointment with your doctor through the apps. It's a Google, it's an iOS Go app, or it's an Android app. So to make a reservation, and when you come to the doctor, you can check the queuing system. When is your turn to see the doctor? So you don't need to come to the outpatient room too early or too late. You're just on time to see the doctor. And you can check all of your data on your apps software. This is another IoT application. Okay, so this is the two applications we have in Taiwan. And I believe because of the IoT technology, because of the wireless sensor, and because of the cloud application, our life will become better and better. Our life will become smart and smart, and will become intelligent world. Thank you for your time. Thank you.
Thank you very much, Mr. Ho. I would like to invite Jean-Louis Massaut, who is the director at Smart and Connected Communities at Cisco, based in Dubai. Jean-Louis.
Good morning. I think it's starting, yes. Good morning. And we just have seen two very interesting applications of IoT for smart cities. And in my presentation, I will also cover a few of the deployment that we have done. And contrary to what the moderator have told us, I don't think we are in a hype situation. I think we are in a real market that is growing and that is very interesting for all of us who are involved in IoT and smart cities. And before I talk about IoT and smart cities, I just want to frame the discussion and talk about what we refer to as Internet of Everything. Everything being connected, offering unprecedented opportunities, but also looking at things, data, processes, and people. And this is what we call Internet of Everything. If you connect things together, you don't derive value. That's only when you connect things with people, with processes, and with data that you can make sense of it and deploy smart services for cities. That's a very important distinction in our opinion. Now, if you look at typically what is happening in cities, you have a lot of different silos. You have lighting, you have control center for the city, you have smart grid, parking, ambulance, and all the way to home energy or factory optimization that we have talked about. And there are a lot of IoT applications that are serving these different verticals in isolation. And this is also the case for cities. We see that today cities are addressing these different challenges that they face in traffic management, in public safety and security, or city lighting, or pollution monitoring, waste management, parking, mobility in general. It's all addressed in silo. There is no sharing of infrastructure, cost, or IT resources, no sharing of intelligence, and there is a lot of duplication of investment, and it's obviously also very difficult to scale if you have to replicate these different investments across the different silos. And I guess you have understood Cisco coming from a networking platform where we can tie this together and add a lot of value if we are clever about it. And this is the core of my presentation. And it's a technical workshop here. It's a technical track. So this slide is a bit technical, not too much. But let me go through what we have here and what is of interest. At the bottom, we have the sensors. And these sensors are typically active in a particular vertical, whether it's, waste bin sensors to monitor if the waste bin is full or not, or street lighting to monitor the street lights and their status, or people counting, and so on. These sensors are actually connected through an infrastructure network that is pervasive in the city, which is Wi-Fi, wired, or other type of radio frequency protocol. And this layer is also in the Cisco environment capable of doing local compute and local analytics. This is what we call the fog computing. The capability on a Cisco router to be able to do some compute, some intelligence, get some intelligence out of that data, to be able to get some intelligence of that video camera that is on the top of a pole, and not only streaming video, but also already identify in the view of the camera if a parking spot is free or not. This analytic runs locally on the camera. And it brings a lot of value to the application vendors who have access to that information. So the layer above is a traditional network. All kinds of protocol, as we mentioned, can be supported. And then we have a layer on top of it, which we call city infrastructure management, where we have a lot of modules around location-based services, around security, around storage, etc. And the value of this is that we bring APIs and SDK, ADIs and SDK to the different application providers that are on top. Whether they are transport management or parking management, they get a lot of data that is processed, that is stored, and that is coming from sensors that are active on multiple verticals. If you have one temperature sensor, you don't need to have one for each of the verticals. You have one sensor, you get the data. If you have a video camera, you can use that video camera for multiple purposes. You don't need to multiply the camera across the different use cases. You can use your camera, of course, for safety and security. You can use your camera for to monitor parking. You can use your camera to look at no loading zones, or loading zone, no parking zone. You can use your camera also to do traffic incident management on the highways and on the main streets, etc. you get the point. And the other element is that all of that data that is coming from that city infrastructure management can be offered through open APIs to third-party developers, to citizens, in an open data manner, so that the local ecosystem in the city can make sense out of it. And that's something which resonates quite well with cities official worldwide, so that the local ecosystem can create application, can create mobility application, can create applications that are useful for citizens, whether they are monetized directly or they are done by research universities and so on. And that's what we have seen, for example, here in the city of Barcelona, where an ecosystem has been built and have access to this data. And as you can see also, because all of that is running on a network, which is public or private, we can also offer all of these applications to multiple cities, if we want, from the cloud, and offer parking management, smart parking management as a service with the application running on the cloud for multiple cities potentially. And we have a partner on our Cisco booth that is offering smart street lighting as a service also from the cloud. We have another partner, and that partner is called Sensity, another partner called AGT International, doing safety and security and doing traffic incident management. We have another partner doing smart parking and location-based services. It's a company called World Sensing. And then the last partner we have is Pacific Control, which is a partner more involved on the building, on the smart building management side. So interesting architecture that is not hype, where we have real application that are ready for cities to deploy. We are also bringing at the lower level a multi-service sensor node, which is sitting on the top of a light pole. It controls the light poles, but it has also sensor around temperature. It has an accelerometer. It measures, of course, ambient light, power monitoring, motion detection. It enables also audio and video both ways, and some other sensors like real-time location services or a number of CO2 measurement, UV, ultrasound, etc. And that multi-service node is actually extremely powerful because it's in the street. It takes the power of the light pole. It controls the light pole properly, and it can be used by the multiple verticals I've just talked about. My last slide is to summarize the trends that Cisco sees in IoT applied to smart cities and how they can benefit to cities and to partners worldwide. The first one on the top, we mentioned solutions as a service for cloud providers, and also giving the capability to manage services operator to scale. It also gives city official the capability of having a smart solution at a very, very low cost because of the scale of the partners. The second point is around big data and open data. And city love the ownership of data because they can monetize the data. So open data and big data is quite critical to build that ecosystem. The third piece is the layer of city infrastructure management, offering strong APIs and SDK so that we can build the robust smart services solution providers in each of these verticals. The layer below is the fog computer layer with the IOX solution running on a Cisco router capable of getting third-party signals and radio frequency, and as well as embedded analytics. And the last point is the multi-services node that I've just mentioned, which is kind of a breakthrough for many applications. That summarizes my presentation. Thank you.
Thank you very much, Jean-Louis. I would like to invite Donald Clark, who is the VP and Schneider Fellow at Schneider Electric, to be our next presenter. And Donald, if you can, I think if you can go play for your, yep, there you go.
These computers, they're wonderful. Good.
Yeah.
Well, good afternoon. I'm honored to be here. I think this is my 4th Smart City Conference, and I'm honored to be in a session that's sort of an inaugural session, which is the Internet of Things. I'm very excited about that. And for those of you who don't have much of a background with smart cities, this is the first time that this notion of Internet of Things has been presented at the conference. And if you look around, every seat is taken and there's standing room only. I think it shows the interest and popularity. I want to try to shed a little light. I'm not going to make an advertisement for Schneider or Wonderware. I'm going to try to shed some light on what the Internet of Things may mean if you're new to the subject. And I think you're going to be pleasantly surprised that it's not some esoteric thing that you need to learn about. And I'm going to show you with some examples that you are very familiar with the Internet of Things. It's not as complex as we might want to make it out to be, but it provides an interesting opportunity in the area of smart cities. All right, there we go. Our vision of the Internet of Things, of course, echoes much of what you've heard from the preceding 2 speakers. Svetlana introduced the subject very well, and I'm sure you're going to hear a lot of common threads with the speakers that come after me. Our vision is to recognize that connectivity in itself is not the answer to the Internet of Things. It doesn't enable smart cities. It is a very important contributor. It is a necessary but not sufficient component. And I think that you're going to see in the course of this presentation that there are several facets to what Internet of Things means as it applies to a smart city. What I've got here is a picture. I think it was similarly portrayed in the preceding 2 presentations. I'm sure you're going to see it throughout not only this session, but throughout the conference, of the multiplicity of the facets involved with smart cities. And you can read them. I'm not going to review them. Public transportation, power, lighting, safety, parking, even aesthetics things like fountains and irrigation for gardens and so on. The opportunities are boundless. And in the very center of this, we're hopefully depicting a citizen, not necessarily a government, maybe a government who can provide this, excuse me. But the end goal should be the individual citizen who is empowered and whose life is improved by the Internet of Things. Svetlana, would you bring my water? Oh, thank you. Thank you. When we talk about the Internet of Things, one of the great things that has happened recently to the portfolio that I represent from Invensys, Wonderware, and now with Schneider is the breadth of the portfolio from power generation, transmission, building management, our smart cities, and so on, is something that we have been doing for, quite frankly, many years. Even before, I think it was Cisco that coined the term Internet of Things. Even before that term existed, people were using that sort of functionality. So our vision is to take full advantage of that and provide not only connectivity, but functionality. I'll be talking to you in a few minutes about, I mentioned some examples. And examples abound, not only in terms of personal knowledge that you have, but experiences. For example, the airport, if you flew in to Barcelona Airport, all of the elements of the airport that are not associated with the airplane, so all the elements associated with the elevators, baggage control, lighting, all of those elements have been integrated together in a cohesive way so that the airport authority has a common control area, a monitoring station, that can look at all of the elements, and that was provided by Wonderware Schneider Electric. The key technology that's involved there is not to put in all aspects with our brand on it. The key element is to tie what is already there together, to provide not only vertical integration, but horizontal integration. And you can see on this display, again, it's very similar to my colleagues in terms of the kinds of activities that are provided. But the key that I want to focus on is this very last box. The Internet of Things includes functionality as well as connectivity. And it must be in mass, a very, very large volume of information, and it must be in real time. Would you like an example that you're very familiar with? Your human body. The human body is a cluster of Internet of Things, because though your brain controls certain supervisory activities, the rest of your body, your pancreas, your liver, your intestines, your heart, they operate with certain functional, very fit-for-purpose functionality. The heart knows what it has to do. The lungs know what it has to do, but they report up to the brain. If that was not the case, you could not go to sleep. But we all sleep very nicely. So the Internet of Things is more than communications and connectivity. It involves fit-for-purpose functionality, a very large volume of activity, and it has to be in real time. If the information is late or delayed, it is useless. So the challenges. We're very familiar with the world of IT, which has managed very well businesses and people. And there's also something called operational technology, which is used, for example, in manufacturing plants, industrial plants, wastewater, power generation. And those two worlds are don't much talk to each other. What the Internet of Things is going to allow is the intercommunication between IT and OT. And it's going to be leveraging these various elements that I've listed here. So in conclusion, excuse me, in all, IoT and big data is easy to say. Oh yeah, we've got IoT, we've got buckets of it. How many tons would you like? Big data? Oh yeah, we got plenty of big data. And that's all very important. And communications and connectivity are extremely important. But IoT is more than connectivity and big data. It must include functionality at the lowest level. Some people call this at the edge, and that's fine. I call it at the lowest level. So your heart is controlled by your heart. If I decided to say, everybody in here, I want your heart to beat twice as fast as it's beating right now, nobody could do it. But yet, if you go run 2 or 3 times around this building, your heart is going to beat about 4 times faster than it is now. Why? Because the heart has fit-for-purpose functionality, so does your kidneys, your liver, your pancreas, etc. Would you like a very simple example of the Internet of Things? You go to the grocery store, you buy a can of soup. On the back of it is a barcode. That is an Internet of Things, because it is a fit-for-purpose information technology that is applied to the can. How much did it cost? Not even a penny. But it serves a fit-for-purpose need that's part of a larger system. The scanner at the checkout, the inventory controllers, supply chain management, so that when you swipe that can of soup, there's another order placed to replace it. That's the Internet of Things. It is fit-for-purpose functionality, it is real-time, it is at the lowest level, but yet it also communicates. So it has to also be in huge scale. Another example, I mentioned your heart. There are 25,000 control loops in your heart that controls oxygen level, breathing rate, pulmonary, blood pressure, heart rate, you name it. The last I checked, nobody in this room paid much attention to it because it has fit-for-purpose functionality at the lowest level. But if you have a heart attack, your brain will say, I need to take action. I need attention, I need help, I need a doctor, I need a hospital. That's what the Internet of Things can do. And cities, last, do not have budgets to say, right, I want to take my city, Los Angeles, and I want to make it a smart city. How much do I owe you? Nobody's going to do that. They want to take A, what they have, and B, they want to be able to implement it gradually over time. Well, I'm running out of time, so I want to turn it over to my colleagues, but I hope that I've given you a little bit of a better definition of the Internet of Things. It's not quite as daunting as you may think, and it's something that you're very familiar with and been using all along. Thank you.
Thank you very much. Thank you very much, Donald. I think we'll come back to that topic of bringing it to the cities after the presentations. And I would like to invite Miguel Alemany from Thyssenkrupp to talk about the Internet of Things as you know it.
Okay. So good afternoon. My name is Miguel Alemany. I work for Thyssenkrupp, and what I would like to talk today to you is about the Internet of Thyssenkrupp things. Because when we talk about Internet of Things, what we are talking really is about Internet of our things, and it's Internet of our things for a purpose. And this is what I would like to show you in this brief presentation. So we are doing elevators. You all know elevators. Maybe you don't know when the elevator was invented. This was 1854. And the guy you see there is the one that is acknowledged as the inventor of elevators, because he basically had a smart idea. The elevator needs something that in case the ropes are cut, you don't fall down and die. It's simple. And he invented this smart safety device, and he tested in front of an audience just by cutting the ropes in this platform you see there. He is the inventor of the elevator, acknowledged like that. But from that, the cities changed, and really the elevator makes a big transformation in cities. Today, you can see the success of this invention in that more than 12 million elevators are installed worldwide. And every day, more than 1 billion people is using these devices. So this is really one of the best or most used transportation systems. And this is in the cities. But from that point, we are in a very conservative industry. So this is a product that has changed little. I think that the biggest change from the startup of elevator was when we created the autonomous elevator. So before you were having the operator, now everyone operates elevators on their own. So this was probably the biggest change. But in general, we are speaking about a conservative industry. And this is a device that everyone likes to have running. And when do you know that something is going wrong? So the worst case, you know it when you get trapped into the elevator. This is something that you don't want to experience. The best case, you might feel some noises, anything that is not running properly. But this is you. What about us? Us, as the responsibles to keep this thing running, We only know that this is not working properly when someone is calling us. So this is the background, and the topic is what can we do to make this better? And there are two approaches for that. The traditional approach, this is you have a bunch of engineers in the lab creating several test devices, and you start creating a hypothesis, and with this hypothesis you are making tests and you are creating algorithms, and then you send information from the elevators to your private server, and you try to make this more or less anticipate what will happen. So this is a strategy, but we decided to follow a different strategy. We decided to use Internet of Things because we believe Internet of Things is providing today the tools we need to really increase our uptime in elevators. So what are we doing? We are just sending tons of data that we already have in our elevators, in our sensors. And we are sending all this data to the cloud. And already in the cloud, we have software and intelligence that is able to analyze this data and identify patterns. So it's not anymore our, let's say, lab people that is creating these nice algorithms and theories. It's already the machine learning system that is identifying patterns and telling us what will happen with our elevator even before it happens. But it's not only that, it's that we will, or we are receiving this data, and the technician also is knowing before he goes to the job site what is happening. And with this information, he already brings with him the parts that they need. And on that way, he can reduce dramatically the time he needs to make any repair on site. But it's more. So if we are able to see how the elevator behaves, we can anticipate failures and we can fix them even before they happen. So we can fix them in our normal monthly visits to the elevators. So at the end of the day, what we are doing is increasing our predictive maintenance performance to a higher level. And this is exactly what we are working for. We are working for to provide uptime to our customers and our users. You might wonder, why are not we doing that today? Because as I said, so we could do that with our, let's say, traditional approach. But basically the problem is that you have a very broad install base with different configurations, different technologies. So trying to make this with today's approach in a traditional way, this is probably a non-way path. So in essence, what do we need to make this happen? So the first thing, we need the controller box of our elevator. This controller box is collecting all the information. And this information is sent with connecting devices to the cloud, where do we have all our intelligent systems that are able to create these algorithms that will make our Internet of Thyssenkrupp things happen. And today this is possible because you can handle a lot of data easily and with a relatively low cost. So to do that, as of today, we have chosen as a partner, we have chosen Microsoft. Why? Because they really have the platforms to make this happen today. So they have the infrastructure as a service provider, they have the devices to connect, they have also the software. They are not the only ones, but they have all that. And for that reason, we have chosen that. And if we think about the future, how our future will look like. So first, think about our call centers. So our call centers will have information in real time of what is happening with our elevators. They will have alerts, they will have what is going wrong, they will have everything about the elevator. And so they will have our technicians. So our technicians, they will have their iPads or any other tablet device in which they will see real time what is happening. And they will be prepared to make whatever is needed to in the field. But it's not only that, we will be able even to do maintenance from remote side. So we will be able to enter an elevator from the call center and make maybe some adjustments into the elevator to make it work properly. Or we might be sending to our technician this troubleshooting guideline. So what is the possible cause of a failure? So this could be sent to the technician, and the technician basically can easily fix what is happening there. Or even the technician can input back. Yes, I was there, you were telling me these were the 4 possible causes, but by the way, this was not any of them. So basically, we identified that this was this roller that was happening, and he can input this back into the system, and this can improve still our predictive patterns. But not only that, so being there, being connected to the cloud, we could even anticipate further interaction with other city providers of services. We could imagine of patterns of movement that are affecting also the patterns of use of our elevators. Imagine the public transport system is arriving. So, and suddenly you feel that in this building is a peak. So all these can be connected with the Internet of Things. And that's why we choose this approach to make our future job. So I was having here a video, but I don't have time for that, so I will skip it. And maybe later we will talk about that.
Thank you.
Thank you very much.
Thank you very much, Miguel. And I would like to invite our last speaker, Carlos Yubero from Abertis Telecom, the Strategic Marketing Manager based here in Spain. Thank you, Carlos.
Thank you very much. I'm going to speak about what companies like us can do for the Internet of Things, and also a bit of what the municipalities can also do in order to increase or to prepare for the Internet of Things. We have heard this number many times today, 50 billion connected devices. There are other companies that say there are going to be a few trillions, or others that say there are going to be 20 billions or so. Anyway, it's a big, very big number, a huge number. A part of this number, probably 10 to 12 billion devices, are going to be served by traditional technologies, the one that we are using today, either fixed or either Wi-Fi or mobile network operators with a 2G and 3G and 4G. This is going to take a big amount. As our colleague from Cisco said, you can put a lot of devices in one place, in a lamppost or in a traffic light, put a lot of sensors there, just use the energy that you have there, and a Wi-Fi connection, and put a lot of information through this channel. And many of the sensors and information is going to travel this way. And this is going to require a huge impact, because we are talking about doubling the number of connections that we already have in just 4, 5 to 6 years. So this by itself is going to be a lot of work in all the companies and all the operators that are around. But what happens with the rest? What happens with the other 20 or 30 billion devices, or things that are not going to be able to be connected by traditional means? There need to be other ways to connect that. And there are going to appear many technologies that can solve that problem. I'm going to speak of one of them, one that us as Abertis has chosen, and we have developed a network with them. This technology is called Sigfox. Sigfox is a French company, and the product is based in what's called APWA, low power wide area. Sorry about that. So what low power wet area means? There are a lot of devices that are wet area. All the smartphones or phones that we have in our pocket cover a wet area, a few kilometers or a few miles or less if we are in an indoor place or in an underground, and gave a lot of service and a lot of bandwidth. The bandwidth has been growing with the technologies. We all have probably a 4G phone in our pockets, able to go to a lot of megabytes of bandwidth, but they consume a lot of energy. In the other side, there is a lot of sensors that exist today that consumes very low energy and can work with very low energy, but typically they are not wide area. They need access network around them, they need repeaters, they need gateways, and they need a lot of information and a lot of networks to be deployed in order to be able to get the information. That's the reason why these sensors have not really gone far beyond the pilot or the trial in our cities. Because, for example, in a city like Barcelona, if you want to put a sensor in every parking space in the street, you're probably going to need between 10 or 15,000 repeaters or gateways in order to get all the information from these sensors. And obviously, the cities doesn't want and are not there to be network operators. So if they don't have a really compelling reason to put a network in the place, they're not going to do that. And for sure, just parking, for example, or watering of the plants, or whatever use that you can imagine, is not enough for the municipalities to put a network. They may put a Wi-Fi network, because they can get a lot of uses from that, and we'll talk about that a bit later. But for sure, they are not going to put many other networks just for specific uses to get information. So this technology from Sigfox, there are others. We have chosen Sigfox because we believe it is the best technology that is in the market at this moment. What can do? It's a very low power device. It gets 300 times less energy than the similar GSM modem to do the same work. So the battery, if you put the device, if you are connected to the grid, to the energy grid, the only benefit that you get from this pipe is just a green aspect or ecological aspect. If we are talking about billions of devices, the less they consume, the better it's going to be for the planet. So even if you have access to the energy, there is a good reason to try to consume as less as possible. But when you are not connected to the grid, you need your device to consume very, very low energy. So we are talking about a few years of battery life with a device that you can have in your pocket, or many more years with a bigger device that can be in a closet or in a street or in any other place. But even with this low energy consumption, the signal goes many miles. You have the numbers here, it's about 10 to 15 miles in outdoor, 3 or less in indoor. So you don't need to put all this network, all this access network of repeaters and gateways. You just need, as operator, we just need to put a few dozens of sensors in the city, a few thousands in a country, and you can get a good coverage and get all the information from these sensors. There is no miracle here. We are not talking about a new unsuspected technology or a new breakthrough in physics. No, the reason for how we can do that is very simple. This technology is an ultra-narrow band. It's specifically designed for the Internet of Things. The payload is very small. We're talking about a payload of about 13 bytes only as a payload. And you can send just a limited number of messages every day, about 140 messages every day. There is also a reason for that. The spectrum that you use is a free spectrum. You don't need to pay a license for that. So in order to use this technology, the costs are lower, the total cost of ownership is much, much more lower. There is no license on the devices, there is no license on the spectrum, so you can build the devices, put that in the market, and have a very low TCO. So from a city point of view or from a user point of view, you just need to concentrate in the sensor that you want to have or the device that you want to measure or to communicate or whatever, put that in the street or put that in the car or in the machine or in the person, whatever you need to put the sensor, and the operator, in this case us in Spain, will collect this data and will give you the data back to you. Of course, with all the necessary infrastructure, the cloud infrastructure, big data, analytics, and all the information that you can take from a network like that in order to take all the advantages. What we have done in Spain, and I'm going to speak just a little about Abertis at this moment. Abertis is the biggest broadcast operator here in Spain. We manage the broadcast signal for TV and radio for most of the radio broadcast and broadcasters in Spain. We have a few thousand sites in and out of the cities. And we also work very closely with different cities and municipalities and security companies. We manage, for example, the network of Barcelona, and we'll tell you something specific about that in a moment, and many security networks of different police forces. So what we have done, we began the development of this Sigfox network in February. We have developed more than 1,200, we have deployed, sorry, more than 1,200 sites. We cover at this moment just in Spain all the cities bigger than 50,000 inhabitants, and we're working to expand the coverage. Not only in Spain, as Abertis, we manage the network for Spain, but Sigfox has operators in other 5 countries and have trials in many other cities and countries. Roaming is one of the things that is provided with the service. So if the device that you have is moving all around Europe or the world, you are going to have a network that is going to take this data and is going to deliver this data back to you. So what implications does this have for cities? Directly, they can use this technology. They just need to know that this technology exists and put that in their bids, so that different providers around the world will provide this technology for them. They don't need to bother with a network or with anything at all, just with whatever service they want to put in place, with its traffic, pollution, parking, whatever. But going far from just a Sigfox network that we're putting in place, what do the cities need to do? They need to facilitate for all this infrastructure to be put out there. Not the specific Sigfox infrastructure, by the way, because as I told you, just a handful of sites cover all the city. In Barcelona, for example, we have 20 sites to cover all the city. But not talking only about Sigfox, all these IoT technologies are going to need a lot of sites to be deployed in the city. We are talking about small cells, more metro sites or metro cells for the normal 3G and 4G technology, and place for Wi-Fi networks and many other things. So what's an easy thing that the cities can begin to do is just to share the passive infrastructure. The cities hold a lot of infrastructure that is very useful for operators. And when I mean passive, I mean street furniture, like bus stops, traffic lights, lampposts, and also the buildings that they have around the city, whether it's the facade or it's the roof. So if they just put with very simple paperwork, an office or a place within the building, or all the protocols necessary for the operators, when they ask for a space, they can have a quick catalog and an easy way to work and use this infrastructure. The deployment of the different solutions that are going to be needed for the Internet of Things is going to be much faster. That's the easy thing to do. There is a more difficult thing to do that can be done. And for example, Barcelona City has done that, and we are the operators of that, is they can share the active infrastructure. Barcelona used to have a very big fiber network to manage the traffic lights. It's in green during the map. And it has a parallel grid for giving a fiber grid for giving Wi-Fi access points to the different buildings and to the streets. That, you know, Barcelona City has a wide Wi-Fi area. These were different networks. What they did is to put all the different IT networks that they have, they put it together in one place or in one single contract, and they externalized this contract. We won that contract. City of Barcelona is going to save 20% of what they used to pay for maintenance, so it's going to be cheaper for them. And we are going to share this infrastructure with the public use that obviously it should have, but also with private companies, for example, to give Wi-Fi for premium or to give capacity or connectivity with different places that they have. These two are things that can be done by the city, and they can help the deployment of the Internet of Things.
Thank you very much. Thanks. I would like to thank the panel. Thank you very much for your insightful presentations. We have learned all about what is happening in the world of IoT today. We talked a little bit about the semblance of the IoT to the functioning of the body with all of the control systems, and we have learned all about the different applications of the IoT. Unfortunately, we're out of time for questions. So after the session, please come to the speakers, introduce yourselves, and talk to them about the world of IoT. And in the meantime, I would like to thank you for your time, and thank you again to the panel. Thanks. They gave 12 minutes to everyone instead of